my job is to ensure that I run the infrastructure seamlessly. What happens in Airtel infrastructure is something very phenomenal. We process about 70 million records a minute, process about millions of customers on our digital footprint, digital properties, Airtel Payments Bank, Airtel.in, our recharge systems, everything runs on our internal cloud. Now, what problems we faced are phenomenal, and how AI is helping is what we're going to debrief. So here is our problem in September 2016, no different than anyone across the world. So we had 30+ desperate tools working in parallel to make things work. 80% of our infrastructure was complete legacy, bare metal infrastructure. Infrastructure goes down very frequently. Low service path visibility. One of the biggest challenges we've always faced is one application goes down in the service path, the whole ecosystem fails, and the user experience dies, and we never met our business KPIs. The other big problem was looking at 100. So we had about 100K volumes of alerts that were coming into the NOC. It was like finding a needle in the haystack. They did not make sense to even look at any of these things when we were missed, and we had enough problems. The time took to resolve an event was little over 210 minutes. Imagine what would happen in 210 minutes. The time it took even to generate a ticket was 10 minutes, which was completely unacceptable in 2016. And the worst part was we had 50+ incidents every month, which were revenue impacting, right? And automation was non-existent in every shape and form. So what is my current state today? 72% of my tickets are currently auto-healed in my infrastructure. This includes infrastructure, servers, hypervisor, application, web tiers, everything put together. 72% of the infrastructure is self-healed. A 94% drop from September 2016 to till date, 94% drop in incidents, right? 85% in drop of our resource management. We are now able to do complete aggregation of all the events and make things work. And 95% drop in our resolution times. Basically, what used to take 210 minutes currently takes about 30 minutes to resolve, right? So what did change, right? The fundamental thing of us was what was in 2016 did not make sense for us. We needed to change. So we put some fundamental building blocks and said, few things which will make change. In digital properties, when you are offering to customers, the customer needs to look into his experience. He is only quite interested about his experience, right? While everyone is trying to generate MAU on the digital footprints, availability is the biggest challenge, and getting the experience right to the customer is the best thing. Okay, so I'll just run you through the Gartner's AIOps framework, what Gartner recommends. 4 stages: anomaly detection, fault diagnosis, fault prediction, and fault recovery. That's the 4 segments which Gartner recommends in and out. So what did we focus on, right? We focused on 5 fun building blocks for our infrastructure. We said from a KPI-driven infrastructure, we will say from an infra KPI-driven strategy, we will move into a business KPI strategy. One of the strategies we applied very categorically for ourselves is, what is the revenue loss that happens if my application is not available for a certain period of time? What happens to my business revenue profitability that happens? The second strategy we said is agile. Every application needs to be agilely built. The infrastructure needs to be agile. We said, how can we ensure that we are able to quickly deploy our infrastructure so that we are able to serve our customers more effectively? Imagine a situation you are having some promotion going on in the next 24 hours, and you need to be prepared, right? You have no time for days. You have a matter of hours to do it. We said, even hours does not make sense. Spikes do not tell you. You have to be prepared. So we built an agile system which can ensure that everything can be deployed in less than 30 minutes. Security. When you're working with digital properties on payment transactions, user interface, anything on the digital footprint, security becomes inherent. If security is not given the prime motive, then everything would fail. Your user experience is not the right. The fourth building block we put together is intelligence, right? Has been a great drive for cloudification. But when cloudification is done, one fundamental thing which needs to be done is all clouds are great till the time they don't have intelligence, right? You need to build the right intelligence into your cloud infrastructure so that it can respond to events in the most easily and most effective way. If I go back to the slide of Gartner, this is where the whole intelligence needs to be built in. We spent great time determining what the intelligence means. If an incident happens, from the time the incident indicators come through, till the time auto resolution happens, we ensure the intelligence is built end to end. So 92% of the events that occur in our infrastructure, I don't even get to see, no human intervention, just an automated auto fix in less than 7 minutes. Customer centricity. While all these, the first four are so important, if customer centricity is not given importance, if the customer does not have a great experience on your digital properties, it really does not make sense, right? Payments not going through, the customer wants to do a digital transaction, the property is not working, does not really make sense. So we kept customer centricity at the center of everything we did and built the processes around it. I'll spend a few minutes about how we achieved and what we tried doing it. I'll not get into great detail. So these were our guiding principles for our NOC services, right? First was tools. We said, instead of looking at system KPIs, how do we look at business KPIs? So the fundamental breakdown we did is, tools were designed to track business KPIs, not my infrastructure KPIs. They did not make any sense for me. We said aggregation is great, but we need to have intelligence. That's where we said we would build a correlation engine which will look from every single aspect of infrastructure till the business KPI. Let me give you a small example how correlation helps. The user says, I'm not able to access your web page. If you bring in 10 people into the infrastructure, go and tell the IT guy saying that the web page is not working, 10 people will get onto it, and everyone would say it's not my problem, right? And that's the standard statement I always have heard in my life. Everyone is right, no one is having a problem. We looked at every single thing and said where the intelligence needs to bring in. One of the incidents we were working, we just saw that web page is not working, but when we dig deep, the latency on the disk is very high. Right? For that to get to, it would take a couple of hours in any ideal situation to come through. We put everything towards a correlation engine, and now correlation engine detects everything in sequence and just goes and makes a recommendation and fixes it. Automation was the core. We needed to bring in multiple tools to ensure that from a manual operations to autonomous NOCs which we built. So if an event is detected at that moment, a correlation engine comes and kicks in, looks at the complete service path, and after the service path is identified, we know 2 probable root causes, and a workflow kicks in, just goes and fixes the workflow, and no one gets even notified saying that there was an issue. KPIs. One of the key things we realized is if we get our business KPIs and user-centric KPIs, customer-centric KPIs in alignment, all the things will fall in place. So what did we do towards it? We said from an event to ticket, we said we will do complete automation. So no eyes on glass monitoring, just go ahead and create tickets, validation. Ticket to impact, we said once ticket is created, what do you do? Full correlation engine to be built end to end. We will talk a little. And the second most important thing that happens is once a ticket is created, what do you do, right? You have to have people calling out. We said human calling does not really make sense because the volume of calls we need to make is tremendous. We put a voice bot and said, we defined who needs to be notified. Currently, our voice bot makes about 80,000 calls every single month without human intervention. And Just by doing some things very logically, we said 72% of our infra-related tickets are completely auto-resolved. So I'll dig deep a little on the process side. The process has 3 building blocks again: detection, remediation, and prevention. This is our AIOps model. What we do is we take all the traps from every single data source that happens within the infrastructure. It could be an SNMP trap, a redfish trap, anything that happens. We put it in our Hadoop data lake and look at the correlation. If you look at the middle graph, it says, I've taken a simple classic example of an OS performance, DB performance, and the storage performance. We said at a given point in time what happens in the infrastructure for an incident to kick in. We said 3 things are not working in this situation. If you look at the OS performance and storage performance are an issue, the rest KPI parameters pretty much in shape. We go back and tackle and said, is it a storage or an OS performance? In all certainty, it would end up becoming a storage performance because of disk latencies. And that's where the workflow would come in and start kicking in and making all the changes that are needed. One of the big things we have noticed in this process is, how will you get your data anomaly done, right? Data sanitization has the biggest problem. One of the things we had to go back and build is our Hadoop cluster to read data from multiple different sources. We read data from about 200 different sources at any given point in time. How do you do that? Every application has its proprietary way of writing data and reading data, right? We had to first bring in data to a stage where it is readable and consistent in nature. So Hadoop is built in to have that amount of data reading and consistent formats. So these are the 4 further drilling down models for us. We do statistical modeling, behavior modeling of the infrastructure, anomaly detection, and unsupervised learning. So each of these building blocks help us in a very specific model. So the first thing I will throw a little on is anomaly detection. Typical web page not working, payments not happening. We detect the anomaly from a business KPI. Then we let our machine learning models start looking at what is going on across the infrastructure on the data sets that are going in. Then we kick in about 22 different kind of statistical models to look at what exactly and which statistical model needs to be applied. Once the statistical model is applied, we know what kind of workflow we need to kick in and what we need to do. That is where our behavior modeling comes into picture. These 4 models enable us to ensure that 72% of our infrastructure is auto-healed. So this is one classic example of our behavior analysis, right? We have multiple data centers growing on, and the latency in each data center can be very, very different, right? Look at it this way. So one data center link is flapping, right? And the metric on that data, the link goes down, and the all metrics take a hit. So we put our own pingdom and said, how do you look at this? How is the behavior analysis of the customer at that point in time when the KPIs are getting deviated? Once we know what KPI deviation is happening, we just go and fix them in real time. This is another example of network analytics. This is a very classic case. We look at D-7 data points. We look at, say, okay, 7 days back, at this moment, what exactly was going on? If you look at the notification, that's a chatbot which sends out the notifications to our business. In this example, there's a variance of 92.18%. We notify our business users at any given point in time in real time. And if you look at the next event, is that a business notification going out saying that a fix has been done, the variance is less than 30%. So we went very deep into our statistic modeling and said, what really makes sense to business? When a business impacting incident happens, the business users need to know what has happened and how quickly you can turn things around. In our case, that from notification to fixing, everything is automated. And there is no one manning it. The statistical model does it. We have a group of people sitting, looking at failures, why things did not work the way we expect when the automation fails, and we continue to fix them on a regular basis. We'll come to the remediation part. So this is our intelligence layer which we have built. So we take from our ticketing tool all the tickets that get generated. Three ways which come through, incidents, alerts, and changes. These are the three inputs for our infrastructure. Then business KPIs are mapped end to end, and then the correlation engine comes in. We have taken APIs from every single vendor that is in our data center, and we have ensured that the intelligence of the API and the traps is bundled together to initiate a workflow which will fix. A quick example I'll give you. You have cloud infrastructure running, 20 VMs on a single host. Will not create a problem, but if your port channel on the storage side is getting consumed on a specific host, right? Typical issue is to go back, move the VMs one by one from an administrator. In this case, the automation layer determines that through the statistic model saying, this host is causing high level traps, let me go and start moving the noisy VMs. The two decisions it takes is to shut down any VM, which is not necessary at this moment for business, or to ensure that it kills the VM and recreates the VM on another host, which will immediately remediate the problem. Load balancers. So there are multiple examples which we look at it, which said, how can we ensure that each infra incident is managed in the most seamless and the most effective way? So while infrastructure automation has been spoken, a lot has been accomplished. The most significant thing we have been doing in the last 1 year is to automate our security operations, right? While security is the key for everything in our infrastructure because we carry so much of traffic of customers, we do so many payment transactions, security needs to be fixed. Look at a situation where you have a DDoS attack on your infrastructure, it takes an hour for some people to fix it. We currently go ahead and fix it completely in a fashion which is automated, right? In this segment, there is only one thing which happens very uniquely is assessment. While correlation becomes very important in infrastructure, but security assessment becomes the next big priority in the SOC or the security operations for us. So a complete assessment is done on the infrastructure in real time. We ticket and do respond to this. These are some of the KPI metrics end users incidents which we've been able to predict and fix. Today, 73% of our incidents in the infrastructure are completely automated for security standpoint. We achieve 100% by March 2020. So I will leave you with few thoughts while doing this. We had several challenges going during this process. Data aggregation was the biggest challenge we had. Data modeling was another challenge. We had to adapt about 200 different data modelings and identify and fix only on 22 models. And then able to workflow and fix those on real time was the challenges we faced, right? So this is what we wanted to present today. This is our journey. September 2017, 82 resources, currently down by 66% in our SOC. End-to-end story stitched, everything automated. The focus is about automation and aggregation and correlation. That's the story we've been stitching for us, and we've been stitching the same story for a lot of our customers who want to be on this journey path. Gentlemen, that's where I conclude my presentation. Thank you very much.